Here, let's talk about the x and y intercepts of quadratic functions. So if you look at like this first one here, there's no place it crosses the x-axis, so there's no x-intercept. Here it just touches the vertex, touches the x-axis, so you get the one x-intercept. And here the vertex is below the x-axis, so you're going to get two x-intercepts. And I have to point out that these are all opening up, obviously. So I'm talking about a quadratic that opens up, that's above the x-axis, on the x-axis, and goes below the x-axis for the vertex. So how to find the x and y intercepts of a quadratic function? You put in 0 for x to get the y-intercept, just as you would if you're just doing a linear function. And to solve for the x-intercepts, you set the equation equal to 0. I do want to point out, though, and it doesn't really talk about it so much, but this first one does, if you set this first one equal to 0 here, if you took that equation and set it equal to 0, you'll get some answers, but they're not going to be real. They'll be complex. They'll be like with a non-zero imaginary portion. Okay, find the x and y intercepts of the quadratic. F of x equals 3x squared minus 5x minus 2. So the easy one is the y-intercept. So that's f of 0. And that's just going to be where the constant is. So it's going to be 3 times 0 squared plus 5 times 0 minus 2, which is negative 2. So the y-intercept's at 0, negative 2. Now for the x-intercept, that's going to be where 3x squared plus 5x minus 2 equals 0. So we're going to have to solve this. And I can do this by factoring. So 3 times negative 2 is negative 6. Factors of negative 6 that had to be 5 would be negative 1 and positive 6. So it would be 3x squared minus x plus 6x minus 2 equals 0. And so I'm going to obviously factor by grouping here. I'm doing the AC technique. So these group together, these group together. Oh, I should not have done that there. I like to use blue. So we can pull out an x out of the first pair, so we have 3x minus 1. Pull out a 2 out of the second pair, 3x minus 1 equals 0. So we have 3x minus 1 times x plus 2 equals 0. So 3x minus 1 equals 0 means 3x equals 1, or x equals 1/3. X plus 2 equals 0 means x equals negative 2. So the x-intercepts are going to be at 1/3, comma 0, and negative 2, comma 0. Okay, let's see what this says. How to find the x and y intercepts by rewriting the standard form. Substitute a and b into h equals negative b over 2a. Substitute x equals h in the general form to find k. Rewrite the quadratics in standard form using h and k. So like a times x minus h, quantity squared, plus k. When the output of the function will be 0, find the x-intercepts. Okay. So find the x-intercepts of the quadratic function. 2x squared plus 4x minus 4. So our h would be negative b over 2a. So we're looking at negative 4 over 2 times 2. So I get negative 1. So it's going to be f of x equals 2 times x minus 1 squared plus, let's see what that last part's going to be. So f of negative 1 would be 2 times negative 1 squared plus 4 times negative 1 minus 4. So 2 times negative 1 squared, that's just 2 minus 4, so I get 6. Negative 6, I should say. So I'll just do, I can do plus negative 6 or just do minus 6. So now it says solve for when the output of the function will be 0 to find the x-intercepts. I guess it's still the same for the y-intercept, f of 0. And that's just, I think it's easier in the first part. F of 0 is just going to be 2 times 0 squared plus 4 times 0 minus 4, which is negative 4. So your y-intercept is going to be at 0, negative 4. For the x-intercepts, I guess they're saying we take this part, 2 times x minus 1 squared minus 6 equals 0. And we would have 2 times x minus 1 squared equals 6. So we would have divide by 2, x minus 1 squared equals 3. So x equals plus or minus, no, not yet. Kind of run out of space. Is there something down here? Yes, we have more problems. Okay, so we have the square root of x minus 1 squared equals plus or minus the square root of 3. So x minus 1 equals plus or minus the square root of 3. So x equals 1 plus or minus the square root of 3. So our x-intercepts are going to be located at 1 plus, get way ahead of myself, 1 plus the square root of 3, comma 0, and 1 minus the square root of 3, comma 0, because there's two of them. Okay, let's move on to 9 then. Solve x squared plus x plus 2 equals 0. So this is an interesting one because I can already kind of see where this is going. Like that's not going to factor. I'm thinking if I even use the quadratic formula, let's just use a quadratic formula. So x equals negative 1, that's the coefficient to the x there, plus or minus the square root of 1 squared minus 4 times 1, that would be our leading coefficient, 1, times 4ac, c is 2, all over 2 times 1. So we have negative 1 plus or minus the square root of 1 minus 8 is negative 7, all over 2. So x would be negative 1 plus or minus I times the square root of 7, all over 2. The point to this is that this graph would be above, I'm pretty sure it's on this side, but it could be wrong. It could be over there, but it's above the x-axis. So there are, while we can get two zeros, they're not real zeros. These are, they have an imaginary in them, a non-zero imaginary. So they're complex zeros. So we'll be looking at, I guess that's it, negative 1 plus or minus the square root of I times the square root of 7 over 2. Okay, our last problem is an application problem. Pretty fun. A ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by this equation. So, by the way, this general formula, height at time t, is equal to negative 1/2 gt squared plus v naught t plus h naught. And I don't think it's in your book, but I just want to give that to you. Now we're using feet, so g in terms of feet is 32 feet per second squared, and you're asking, well, what is g? G is acceleration due to gravity. If you're doing in terms of meters, it's going to be 9.8 meters per second squared. But we're doing this one here. And that's where they have negative 1/2 times 32 times t squared plus the initial velocity is 80 feet per second. So 80 feet, well, I don't have to put feet, 80 t plus and the initial height, since it's on a building and it shot up, the height of the building was 40 feet. So at 80 feet per second plus the 40. So when does the ball reach a maximum height? Well, again, it's a parabola that is opening downward. So where's the vertex? So we're looking for negative time would equal negative b over 2a. So we're looking at negative 80 over 2 times negative 16. So that's negative 80 over negative 32, which I'm not going to guess. I'm thinking it's 2.5, but I'm not guessing. I'm going to my calculator to do this. Yep, 2.5. So 80 is 2.5. And then what is the maximum height? So what is h of 2.5? That's negative 16 times 2.5 squared plus 80 times 2.5 plus 40. What would that be? So we have negative times 2.5 squared plus 80 times 2.5 plus 40. And I get 140 feet is the maximum height. And then the question is, when is it going to hit the ground? So we're going to take this expression and set it equal to 0. So I'm going to take that negative 16t squared plus 80t plus 40, set it equal to 0. And we can clean that up a little bit. What jumps out at me is if I could divide everything by like negative 8, I'd have 2t squared minus 10t minus 5 equals 0. And there's a part of me that's really tempted to use the quadratic formula now, initially, but I was hoping to clean it up and maybe see something. But 2 times negative 5 is negative 10. I'm not seeing factors of negative 10 that add to be negative 10. So we'll use a quadratic formula. So t equals negative of negative 10 plus or minus the square root of negative 10 squared minus, by the way, that negative and the negative 10 squared gets squared out, minus 4 times 2 times negative 5 all over 2 times 2. So t equals 10 plus or minus the square root of 100. We have a double negative here, plus 50. No, that's not 50. Yeah, that's 2 times 5 is 10 times 4, that's 40. Or 4 times 2 is 8 times 5 is 40. All over 4. So it's 10 plus or minus the square root of 140 over 4. Now I can pull out of 140. I can pull a 4 out. I think that's 35. Yeah. So this would be 10 plus or minus the square root of 4 times 35 over 4. Scroll down. So it's going to be 10 plus or minus 2 root 35 all over 4. So it can be reduced to 5 plus or minus the square root of 35 all over 2 if I divided 2 out of everything. Now that's not terribly helpful. It is for us math people. We love that. That looks great and perfect and wonderful. What the applied people in the world like to see is an actual number. So we have two numbers, 5 plus the square root of 35 all over 2. I'll get that approximation, and then 5 minus the square root of 35 over 2. Now the problem with the second one, that 5 minus the square root of 35, well, square root of 35 is more than 5. It's almost 6. So that's going to be negative. And we can't have negative time. So that one is just not even a realistic answer. So let me go ahead and see what I come up with here for my handy dandy, shouldn't say that, my fun-filled phone calculator, because my calculator is charging. So we have 5. Don't forget the parentheses. We have 5 plus square root of 35 divided by 2. So we're looking at 5.458 seconds. And then for the other one, it'd be at negative 0.458 seconds. And so clearly this is the answer. And that actually is a reasonable answer too. Let me scroll this over a little bit. I think it's a very reasonable answer because given that the vertex happens at 2.5 seconds, this from the top of the building goes up for 2.5 seconds. It's heading up till it stops going up. And then it comes back down. Now, if it went back down just 2.5 more seconds, it'd still be at 40 feet. It's still at 40 feet to go down. So yeah, at 5 seconds, it's at 40 feet, and then it would go all the way down to the ground at 5.458 seconds. So it seems very reasonable to me. Okay, this one went a little long, but I hope you had fun with it too.